Hi there, welcome to my channel Mando to Fundo. In this video, I am going to discuss about the solution to check whether the given string has a valid parenthesis in it. Let's look at the problem description. We are given an input string containing just the characters open parenthesis, open curly brace and close curly brace, and open square bracket and close square bracket. We'll have to determine whether this input string is valid, which meets these conditions. Open brackets must be closed by the same type of brackets, and open brackets must be closed in the same order, and every closed bracket has a corresponding open bracket of the same type. For example, this input we have a open parenthesis and close parenthesis, so this is valid. And in this case, open parenthesis, close parenthesis, open square bracket, close, open curly brace, close curly braces. So this is also true. But this one, open parenthesis, close square bracket, so this is not a valid one. And here, open parenthesis, square bracket, followed by another closed square bracket, and then close parenthesis. So this is a valid input string. So the input length will be ranging from 1 character to 10,000 characters. S consists of parenthesis only these characters. Let's look at the approach to solve this problem. So we have this input string. In order to declare that an input string is valid, that string should meet the following conditions. So the open brackets must be closed by the same type of brackets, and then the open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So how do we remember the previously seen parenthesis and its order? So basically when we see the open parenthesis in an order, the closed parenthesis should be seen in the reverse order for whatever the open parenthesis we see. This gives us a clue. Whatever we put in last should match the one we are seeing, the close parenthesis. So that means last in first of data structure. So stack is the good fit for this. We use the stack data structure to solve this problem. So for example, we are at the index 4. We are seeing the close square bracket. So in the stack, whenever we see a open parenthesis or curly brace or square bracket, we push that onto the stack. Whenever we see a close square bracket or close curly brace or close parenthesis, we have to pop the top element from the stack and compare the one we are seeing currently and check whether they are paired. If so, then we can proceed. Otherwise, we can declare that input string as invalid. So in this case, the index 4 points to the closed square bracket. In the stack, we first push the open parenthesis, open curly brace, open square bracket. So the open square bracket is on the top. So when we pop the top element and compare with the current element, they make a pair. So we proceed to the next and we check this is the close curly braces. So we pop the top and compare whether they are pair. That is also make a pair. Same way this and this make a pair. So we declare this input string as a valid one. So that's why we return true. Let's look at the flowchart. So input for this procedure is an input string. First we initialize the index and the count variable, and then the stack data structure, and also the return value variable, and we set it to true. And count will be initialized to the length of the input string. We check whether all the characters in the string are processed. If yes, we go out of the loop. And we check whether the stack is empty. If so, we return true. Otherwise, we return false. That means we still see some open parenthesis or brackets or curly brace. That's why we hit this condition. Okay, so if there are elements still there, Then we go ahead and check whether that character matches either the open parenthesis or curly brace or square bracket. If so, push it onto the stack and then increment the index and process the next character. Next, we check whether the current character is matching the close parenthesis or close curly brace or close square bracket. If so, pop the top element from the stack and compare whether the input character, the current input character and the top element make a pair. If yes, proceed to the next character processing in the string. Otherwise, there is a pair mismatch that violates the three conditions we supposed to meet. So we go out of the loop and set the return value to false and return the red value. So this will continue until all the characters are processed. If we see any other character, in that case also we come out of the loop and we set the return value to false and finally we return the output. Let's move on to coding. First I create a hash map with one entry for each type of brackets. One is a parenthesis and curly brace and square bracket. Then I initialize the stack and the count variable to the length of the string. Then I will scan through the characters in the string. On each iteration, I check whether the character red was open parenthesis or open square bracket or open curly braces. If so, I push that character onto the stack. If it is a closing parenthesis or square bracket or curly braces, then I check first for the error case whether the stack is empty or not. If it is empty, that means we do not supposed to see the closing parenthesis. That indicates the input string is not in correct format, so we have to return false. Otherwise, we have to take the top element from the stack and check whether it forms a pair with the current character we read. We can look up the pair hash map with the current character for the current character entry. So if the top element and the pair of ch matches, then it is in a correct format. If it doesn't, that means it is an invalid input string, so we have to return false. And then I adjust the stack size. Finally, once we come out of the loop, I return the boolean. The len of stack is exactly equal to 0. Basically, once we come out of the loop, if the stack is empty, that means it is a valid string. If the stack is not empty, that means there are still some open parenthesis or open curly brace or open square bracket is left in the stack. That indicates the input string is not correct. Next I am going to run the test cases. Oops, there is a compilation error. Okay, I think there is a typo. Okay, all the tests passed. Next I am going to submit this program. Cool, it's accepted. Next I am going to do the code walkthrough with sample input. I'm going to use this input for the code walkthrough. This has one pair of parentheses, one pair of curly brace, one pair of square bracket, and also it is closed in the correct order, so the output is true. So let's do the code walkthrough. So first we have hash map called pair. So one entry for the curly braces, one entry for the parentheses, one entry for the square bracket. Okay, so now first we initialize the stack, and the count is for this count is 6. Now we scan the input string character by character. In the first iteration, open parenthesis is seen, so it is pushed onto the stack. On the second iteration, open curly braces is seen, so that is pushed onto the stack. On the second iteration, we see the opening square bracket, so we push that onto the stack. So now the stack has 3 elements, and the top we have the square bracket. On the third iteration, first we see a square bracket. So once we see the closing parenthesis or closing curly brace or closing square bracket, first thing we check is whether the stack is empty or not. If the stack is empty and we see the closing parenthesis or curly brace, then that means it is not in a correct format, so we immediately return. So there must be whenever we see the closing parenthesis, there must be a opening parenthesis seen already, but in this case this indicates the input string is not in the correct format. Okay, so then if it is in the if the stack is not empty and it has some elements, then we pop the top element from the stack, and we compare that top element, and we look up the current characters pair. The both should match. So we are seeing the close parenthesis, not close parenthesis, close square bracket. So there must be a open bracket on the top of the stack. That's what we are checking here. So the top points to the square bracket, and the pair of CH is closing square brackets. The closing square brackets pair is opening square bracket. That is what we are seeing on the top of the stack. So this condition is false, so we are adjusting the stack size and enter the next iteration. So when the iteration 4, we see the closing curly braces, then we check the top of the stack has the opening curly braces. So that's what we are seeing. So we proceed to the next iteration. The final one, we see the close parenthesis. We expect open parenthesis in the stack, so that's what we are seeing. So after popping that element, the stack will be empty, and also we reach the end of the string, so we come out of the loop, and then we check whether we return the length stack is exactly equal to 0. Make sure there are no open parentheses or curly braces or square bracket left in the stack. If they are left in the stack, that is also indicating an invalid string. Finally we return true. So that is the expected output for this input string. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for these two cases. First case, we have three pairs. One pair is parenthesis, the second pair is the curly braces, third is a square bracket. So in this case, we have to scan through the entire input string to declare that it is a valid string. So this for loop runs 6 times the length times length of the string count number of times it has to run. Same way this case also, where it has only open parenthesis, open closing braces, open square bracket. In this case also, to declare that this is an invalid one, we have to scan the entire input string. So the time complexity of this solution is order of n. Next, let's do the space complexity analysis. That is also order of n. For example, okay, let's look at the code. So we build this input map. This is constant because regardless of the input string size, we have only 3 entries, whether it is a 10 byte string or 10,000 byte string. Still this map is going to be of 3 entries, so this is a constant space. And but for the stack, depending on the nature of the input string, it varies. For example, this input case, the size is 6, but we need stack space for 3 elements only. So from the fourth element character onwards, we pop out the elements from the stack. So maximum size of the stack required for this input case is 3. But for this invalid case, we need a stack space which is equal to the number of elements in the input. So the space complexity is order of n. Thanks for watching this video. Have a great day.